28th February, and this day is very special to the scientists because it is National Science Day. This day is to mark the discovery of Raman effect by an Indian physicist, Sir C.V. Raman. He received Nobel Prize for his invention. We all know that our founder president, His Holiness Sri Vibhudesha Swamiji, always wished that any of the students of Purna Prajna becomes the Nobel laureate. So, it is your duty to work hard and contribute something to the society. In our day-to-day activities, we come across many interesting facts which leads to the invention. From the time we wake up in the morning till we go to bed, we enjoy all the luxuries. This is because of inventions due to necessity. You enjoy watching TV, playing games in the mobile, etc. because of technology. Science and technology are interrelated. Science has played important role in curing diseases. Thus, our life without science is nothing. So, understand the importance of science and promise to contribute to our society through inventions. To make this day more special, our teachers, including all the language teachers, demonstrated experiments which are recorded. Watch this video and enjoy the program. Thank you.
Good morning everyone. The science today is the technology of tomorrow. We Indians started celebrating National Science Day from the year 1986 on 28th February every year to mark the discovery of Raman effect by Indian physicist Sir Chandrasekhara Venkata Raman, popularly known as Sir C.V. Raman, on 28th February 1928. He was awarded the Nobel Prize in Physics in the year 1930. The main objective of National Science Day is to bring awareness to people about the importance of science in our daily life and to encourage people by popularizing the science and technology. Every year we celebrate with a theme. The theme for National Science Day 2021 is Future of STI, that is Science, Technology and Industry, Impacts on Education, Skills and Work. The essence of science is independent thinking, hard work and not equipment. When I got Nobel Prize, I had spent hardly 200 rupees on my equipment, says Sir C.V. Raman. Sir C.V. Raman was born on November 7, 1888 at Tiruchirappalli in Tamil Nadu. His father was a lecturer in physics and maths. He obtained BSc degree from the University of Madras. He stood first and won the gold medal in physics. In 1907, he completed his MSc degree at the University of Madras with highest distinction. Raman effect explains the effect on the scattering of light when passing through different materials. Raman established the Raman Research Institute in Bangalore. He passed away on November 21st, 1970. It's our responsibility to honor the great scientist and his innovation by contributing greatly to the field of science through innovation. One science invention can change the world forever. So, I wish all the science students the very best to enhance their scientific zeal and also fulfill our His Holiness Sri Vibhudesha Swamiji's wish to achieve the Nobel Prize in the field of science by following the path of Sir C.V. Raman. Thank you.
What surrounds all of us? Air surrounds all of us. Air is present everywhere. But this air has pressure. I would like to prove air which has pressure with a small experiment. Materials required: a tray or a plate, a tissue paper or an ordinary paper, a small candle which I have placed here, it's already lit, and 3 glass tumbler with little water in it. Now as I placed the plate, I placed a tissue paper and I wet the tissue paper and I placed it at the middle of the plate, and I see that it is fixed evenly and it sticks to the plate. Now you can see the lit candle which I placed it at the middle. Make sure the candle is not too big. It is a small piece of candle which is lit. Now you can watch me. I invert this glass tumbler over this lit candle. You can see the candle is lit. Yes, now it's put off. I just press it at the middle. Now the lit candle which was lit for some time, when I inverted a glass tumbler and placed it at the middle, the lit candle was put off. Now vacuum is created inside the glass tumbler. What is vacuum? When the air is absent and the tumbler is filled with vacuum, this vacuum gives the tray to lift, and now I lift it. The lit candle is put off because vacuum is created inside the glass tumbler, as you would have observed here. Now, what is vacuum? When there is absence of air inside this glass tumbler, vacuum is created when there is no air absolutely. This gives weight to the plate or the tray, and now I lift it. You can see. So there is an upward pressure. Air exerts pressure. Now to prove this, I place another 2 tumbler along with this tumbler, and now I lift it. Now you can see I lift all the 3 tumblers which is placed in the tray. Air exerts pressure upwards, so there is an upward pressure in the air.
Good morning children. Today I am going to do a science experiment about buoyancy. It's related to Archimedes principle. What is this buoyancy? Buoyancy means it's an upward thrust of a liquid or water. What is this upward thrust? Just a minute children, I will show it. See, I am having a ball in my hand and I have taken water in a jar. See the level of water here children, it's still here. Now, as soon as I immerse any item in that water, it is floating. Now I am putting that ball inside. See how the water level is coming up. See, it was still here. Now it is coming up. As soon as the body immerses in the water or liquid, the water level increases. So this is because why the water level increases. This is called upward thrust. To show this experiment, I am having one more experiment children. The things required for this experiment is 2 bowls of water and 2 aluminium papers and 10 1 rupee coins. How to do this experiment? To learn what is this buoyancy will be better for you. For this, these are the requirements needed. Now I will start the experiment children. First, to fill up the water tubs with the water. Then you take one foil paper and 5 coins. 1, 2, 3, 4, 5. 5 coins you put it in the foil paper and just fold it, cover it. Tightly you cover it. And now this I am going to put this 5 coins which is covered with the foil paper and I am going to put it in one bowl. What happened, children? See children, as soon as I have put these coins with the foil paper, it is immersed inside. See, it is going down. Again, one more foil paper I will take and I will fold like this, like a boat shape I will fold. Now I am going to leave this foil paper on the other tub. And now I am going to place these coins so that each coin should have equal distance. Equal distance it should be. In that way we are going to place the coin. See, now this is not immersed. This is not going to immerse in the water. Whereas which I folded in the first bowl, it is immersed. Whereas this is floating. See children, this is floating. Because this is the reason why it is of Archimedes principle. The reason is it is Archimedes principle. It is law of flotation. When the body is immersed in a liquid, it experiences an upward thrust, that is buoyancy, which is equal to the weight of the liquid displayed by it. The weight of the body should be equal to the weight of the liquid displayed by it. The center of gravity of the body and that of the liquid displaced should be in the same straight line. This you should remember children. The center of gravity of the body and that of the liquid displayed should be in the same straight line. Then only it will help it to float. In the first jar, the weight of the water displayed by the coin is less than the weight of the coins because the coins are placed in the foil which were just not in a straight line. Hence, the upward thrust of the water is less, so coins were immersed. Whereas, in the weight of the coins is equal to the weight of the water displayed by it because the coins are placed on the foil paper in a straight line in the equal distance and it is in straight line. This is how when the body is immersed in the water it will flows and this is the upward thrust of a liquid. Now you might have understood children why when the iron ball is put in the water it will be immersed and why the boats will be sailing on the water. This is buoyancy. Thank you children.
Hello children. Science is not just science, it's magic. Shall we do one magic with a balloon? Shall we start? See children, the balloon is inside the water bottle. It is not moving at all. It moves by my command. Now I am giving the command, move. See it is moving. Again, move. It is under my control. I will tell you how it works. Take a water bottle and tuck a balloon inside it. Before that, it is very important, make a small hole with the thumb pin or push pin. Now tuck the balloon inside the water bottle and wrap the balloon to the neck. You should hold it properly, wrap the neck of the balloon to the nozzle of the bottle
like this. Now blow up the balloon. When it is got inflated wholly inside the bottle, stop it. Now shall we? Before that, where is that hole? You should see the hole. Close the hole with the finger properly. Then again release the hole and blow the balloon. Now cover the hole with your finger. Let your finger off the tiny hole. Now balloon moves itself. As you cover that hole with your finger, it stops. See, again it is moving. What is the science behind this magic? When we blow this balloon, the air inside the bottle moves out of this hole. Then this space between balloon and bottom of this bottle becomes empty. Then the pressure will be more outside and this inside this balloon. It tries to pull it to the empty space. Because of that, the pressure creates and the air will not go outside the balloon. When I release this finger out of this hole, the pressure occupies the air occupies the empty space and air comes out of the balloon. Are you ready to do this magic at home? You try this at home once.
Good morning children. Today I am going to do an experiment about conduction. What is conduction? Heat is transferred from one molecule to another without actual movement of molecules. No motion of matter is involved in conduction. To show this, a small experiment is done. Take a knife and place few pins and place it like this. See that each pins are close to each other but not overlap. Take a candle and fix the pins to the knife by heating the candle wax. Now take the knife and bring it near the candle tip. Now we observe first pin is falling down. Now one by one all the pins will be falling down. You can see that all the pins have fallen down because of the conduction of heat is transferred from one pin to another. Thank you, children.
Hello children, today I will be conducting an experiment on capillary action. So this experiment shows how the water moves from the roots through the stem to all the parts of the plant. So this capillary action, it is just opposite to gravitational force. So gravitation, I know everyone is aware of what is gravity. That pulls the object towards the earth. So this capillary action or capillary force is quite opposite to that. It pulls the water from the ground towards the other parts of the plant through the stem. So this is what we will be showing in this experiment. So to be more clear, as we humans have heart which pumps the blood to all the parts of the body through veins and arteries, in similar way, plants have xylem which moves the water from the ground to other parts of the plant through the stalk or the stem of a plant. So we will be seeing this experiment, how it is moved, how the water is moved. So xylem is called the transportation system of a plant. So the materials required for this experiment is, we mainly use the Xenial flask. Either you can use celery stalks or you can use a balsam plant which has a transparent stem. As I did not get this, I have used the Xenial flask which has white petals, and 3 jars and some food colors, or you can use even watercolors. And be careful, instead of you don't use any acrylic colors or oil paints because it doesn't dissolve in water very easily. Food colors or ink or watercolors, they dissolve easily in water, so such type of food colors or watercolors you can use. And then water. I have used the other colors like blue and an orange food color, and this is a pure water which I have got, and these are the Xenial flask which I have used. For this I have to just cut the stalk of the plant, stalk, so that it is exposed easily to the water. Then I am placing this into the pure water. Then one more stem, cut it, and then you can just place it in one of the colored water. Then again you can just place it and place the other flower into the other colored water. So after few hours, you can see how the water is being transported from the stalk to other parts of the petals. Here, as I have used a flower, you can see the color of the petals, the edge of the petals have been changed to yellow color or orange color. Here, as I have used an orange colored water, and here I have used blue. So here the petals have been changed to that is the edge of the petals have been changed to the blue color. And this is the pure water. Here you can't see any difference because it is a pure water, but here as the water is colored, you can view or you can observe the difference here. So this is the capillary action which moves the water from the stalk to the other parts of the flower. That is, each and every edge of the flower of the petal is being colored. So if you want a more clear result of this, so here you can observe it is totally being changed. This is the original flower, whereas here you can see the change. So if you want a more clear result, you can keep the flowers for the overnight so that the color of the flower will totally be changed. So this is called as capillary action. And this is how you can change the color of the flowers. If at all you want yellow or green, any color, food color you can add, and you can change the color of the plant. So this is called as capillary action in plants. Thank you, children.
Hello everyone. As we know that cosmetic become our part of life nowadays. Cosmetics like spray, perfume, deo,
these are inseparable from our life. Nail paint is one of such cosmetic which we cannot think to move from our life, to move out from our life. Okay? But do you know that nail paints are highly flammable? They have such a flammability that even water cannot resist it. So here today I am going to conduct an experiment to show the same. It will show you how nail paints, even if we keep it in water, it will not work. Although we know that water is the best extinguisher, but even if we keep the nail paint in water, it catches fire. Now I am going to conduct experiment. For that experiment, what we need is, we need water at room temperature, a glass tumbler. Why I am taking this glass tumbler? So that it will be clearly visible to you. A matchbox and nail paints of any brand we can take. So what I am going to do, I am just keeping water, filling glass tumbler with water. Now I am going to put few drops of nail paint in this. See, as you can see, the nail paint is not soluble in water, and even it is not sinking. It is on the surface of water. Now I am going to lighten it. We'll see whether it will catch fire or not. So you can see it catches fire so fast. Can you see it? See? Even water cannot help it. Even water cannot resist it. So what I want to say, we can use nail paints, but we have to use very carefully. We have to use it very carefully, and we have to keep this out of the reach of children. And we should not keep it near gas stoves and all. And this property, why it is flammable, I just want to explain you why it is flammable. Because of the presence of acetone in this. Acetone is a chemical which is present in nail paint. The more the presence of acetone, the more flammable it will be. See, can you see? So that's it for today. Thank you.
Hello everyone. Today I will be conducting an experiment about the centrifugal force. What is centrifugal force? It is a force required to move the object away from the center of the circular path. The centrifugal force is used in dryers in which the wet clothes are whirled in a wire basket. Chemists and biologists use centrifuge device working on the centrifugal force to separate suspended solid matter from a liquid. So let us try an experiment doing this. So for this, the materials which are needed is a basin full of water, a bowl and a color liquid. Take a small amount of water in a bowl. Put a few drops of color liquid in it. Take the bowl and place it on the water surface of the basin. Now start spinning the bowl. Spin the bowl continuously. What would you see? If you spin continuously, you will see a white ring at the center of the bowl. Bowl continuously, what would you see? If you spin continuously, you will see a white ring at the center of the blue solution. What does it happen? While spinning the bowl, it exerts centrifugal force in the liquid. The blue liquid has white substance. When the mixture is whirled rapidly, the difference in centrifugal force on the white solid materials
on the less dense liquid causes a solid to collect at the outer rim. Hope you all have understood what is centrifugal force. Thank you, children.
Hello children. Electric energy. Electricity is a form of energy which is produced by the movement of electrons. Electricity, two types of electricity. One is static electricity, second one current electricity. If electrons are localized, it is static electricity. If electrons are flowing, it is current electricity. Today, I am conducting an experiment to understand what is static electricity. It is required an inflated balloon, few pieces of papers. Now, I rub the balloon against the air. Hold the balloon near the pieces of paper. You can see few pieces of papers are attracted to the balloon. This is because static charges are there on the balloon. Thank you, children.
Hello students. Today I will conduct an experiment on acid-base indicator. I will make an acid-base indicator with red cabbage. Okay, you can also try this at home. I will make a red cabbage juice with some hot water. Okay, to extract juice from red cabbage, you can use hot water and nicely grind it in the mixer grinder. Then strain that solution to avoid pieces of red cabbage. Here we have a purple solution, and this solution acts as pH indicator. Okay, pH indicator means it's an indicator used to determine whether the solution is acid or base. Okay, this purple solution, if it reacts with acidic solution, it turns into red color. Okay, reddish orange sometimes according to the acidity of the solution. When it mixes with basic solutions, it turns into greenish yellow color. Okay, in this red cabbage, a substance is there, flavin. This substance gives its property. Children, here we have red cabbage solution. This acts as our acid-base indicator. Okay, it's purple in color. And I have taken 5 different solutions which is easily available at home. Okay, you can prepare at home. This is lemon juice, then vinegar. It's normal tap water. Here baking soda. I have made baking soda solution. Okay, 2 spoons of baking soda with water, normal tap water. Then soap solution. So let's see what will happen if I mix this red cabbage solution to this. Okay, so first I am pouring little red cabbage solution to lemon juice. See children, the color turns to red. Then to vinegar. It's light pinkish in color, isn't it? This is normal tap water. No color change, isn't it? This is baking soda. Then soap solution. When we mix red cabbage solution to this, in lemon juice it turns into dark red color. In vinegar it turns to light red. In water no color change. And in baking soda it turns to dark green. And in soap solution it turns to light green. This acid-base indicators. One example is red cabbage solution. It's an indicator used to determine whether an aqueous solution is acidic, neutral or base. Indicator reacts with hydrogen or hydroxide molecules present in the aqueous solution and changes color. Stronger acids will have less pH, stronger bases will have high pH. And this pH varies from 1 to 40. pH means power of hydrogen. The hydrogen molecules present in the solution determines the pH of the substance. Aqueous solution with a pH of 7 considered neutral, example water. And aqueous solutions with pH range from 1 to 6 considered as acids. Examples lemon juice, vinegar, hydrochloric acid, etc. And the solutions or substance with pH from 8 to 14 are considered as bases. For example, soap solution, baking soda, these are all bases. Thank you, children.
Hello children, have you all tried lighting a matchstick, applying toothpaste at the edge of the lead? Now I will conduct an experiment to prove DIY toothpaste and matchstick experiment. Materials required for the experiments: a bowl, toothpaste, tissue paper, matchstick and water. Procedure: place a bowl, pour the water in the bowl, take few matchsticks, drop it in the bowl of water. Now you can observe matchstick become wet. Now try to light up. Matchstick does not light because it is wet. Again I will take few more matchsticks. Apply toothpaste at the edge of the lid. Drop it in the bowl of water. Leave it for some time. Take a tissue paper. Wipe the toothpaste and try to light up. Now matchstick light up. I will try one more. Wet matchstick don't light up because it is wet and the friction is ruined. Matchstick ignite due to extreme reactivity of phosphorus and the chloride mixed in the matchstick's lead. Paste contains sodium fluoride and triclosan. If you all want, you can try this experiment. Thank you.
Good morning, children. Let's do an experiment so that we can learn what is meant by air, pressure and volume. What is meant by air pressure? Air pressure is the weight of air molecules pressing down on the earth. To do this experiment, we need water, 2 balloons, candle, matchstick and twine. Okay, let's start the experiment, children. Now I am going to take a balloon and blow it to its maximum level, and I am going to tie its mouth with a twine. I'm going to place it here. Now, I'm going to take the balloon and place it on the candle. Let's see what happens. Yes, it bursted. Isn't it, children? Children, it bursted. Why? Because while heating, the air in the balloon expands. Since the volume of the balloon is the same, the expanded air pushes the wall of the balloon out. Since the pressure of the air inside the balloon is more than atmospheric pressure, means pressure of the air outside of the balloon bursted. Now, children, I'm going to take the second balloon and pour some water into it. Now, I'm going to blow it and tie the balloon tightly. Okay? Now, let's place this balloon over this candle. Children, did you observe? It did not burst. The balloon does not burst. You know why? Here the water in the balloon takes the heating energy to boil. So, it does not burst. But, if you heat for some more time, the water in the balloon would be boiled. And the boiled water makes the balloon burns by its high temperature. Children, hope you all enjoyed the experiment. Thank you.
Hello children, I will be conducting an experiment on inertia. What is inertia? It is the property by which matter continues in its existing state of rest or line of motion unless acted upon by a force. Things required for this experiment: a jar, a card and few coins. First, place a card on the jar and take 2 coins, place it on the center of the card, flip the card with the help of the finger. See what happens. While the card moves fastly and fell on the table, the coins fell into the jar. Why does it happen like that? While flicking the card in motion. At the same time, the coins continue in their existing state of rest. It means that the coins are in inertia. Inertia means not moving. The coins are acted upon the force. So the coins fell into the jar. You all understood? This is an easy experiment. You all can try at home. Thank you.
Okay, we will understand about energy, children, today. What is energy? You all know energy is the ability to work. Energy is the ability to work. There are different forms of energies. Which are they? Mechanical energy, heat energy, light energy, sound energy, electrical energy, chemical energy, solar energy, atomic energy. So many types of energies are there. Today, we are going to concentrate only on mechanical energy. Why? Because mechanical energy are of two types. One is potential energy and the other is kinetic energy. So, potential energy is what? Potential energy is the energy possessed by an object due to its position. Potential energy is the energy possessed by an object due to its position. For example, an object which is at a greater height, which is kept at a greater height, it will have potential energy. Or one more example I can give: water stored behind the dams. They possess that water possess potential energy. And kinetic energy. We shall go on to kinetic energy. What is kinetic energy? Kinetic energy is the energy possessed by an object due to its motion, due to the virtue of its motion. So, while moving, it gains some energy. And when any object starts moving, then it gains some energy. This energy we call it as kinetic energy. So, for that, a moving car, any object which is moving will possess, or ball which is thrown, that also possesses kinetic energy, because it will be moving. Any object which is moving possesses kinetic energy. So, today we are going to understand what is potential energy and what is kinetic energy through an experiment. Okay, children? Come on, let us see. Children, today we are going to learn what is potential energy and kinetic energy. So, to know that, we need few things. That is a channel like this with a cardboard, made of cardboard, and two balls and a towel. Okay, the towel should be spread on the floor like this, and we have to place the channels in such a way that their heights should be the same. You can see the heights are same. See, there are differences in the lengths, isn't it? This is long and this is small. Even then, when we leave the balls together from the same height, they are going to travel same distances. We are going to check now. See, you could see those two balls are lying in the same line, isn't it, children? Why is this? This is because the two balls that were about to be released have the same potential energy, because they are at the same height. They were at the same height. So, as they roll down, the potential energy gradually converted into kinetic energy. So, what is potential energy? You all know that potential energy is the energy possessed by an object due to its position. So, for that, I would like to explain once again. See, the potential energy is nothing but it is the energy possessed by the object due to its position. So, both were at the same position, right? Same height. And what is kinetic energy? Kinetic energy is the energy possessed by the object due to its motion. That's why when they were released, potential energy got converted into kinetic energy, and they possessed same potential energy. That's why they rolled down and they traveled the same distance. Did you understand now what is potential and what is kinetic energy? Thank you, children.